Hello all the participants, I am Sumit. Today's topic is the analysis of the flood characteristic under the different water release scenario in the Prek Thnot River Basin. And here is the content. Today's presentation will be divided into four main points. The first is introduction, second is the methodology, and the third is the result and discussion, and the last one is the conclusion. We start off with the background. As we know, there are two types of the flood management, the structural and non-structural measure. For the structural measure, we define as the prevent harm in the flood risk system based on the hydraulic engineering work. Another way to prevent harm from the flood risk is the non-structural measure. For instance, by using the model and reservoir operation. The flood is the risk in the area along the river Prek Thnot, and it happens frequently, especially the southern part of the Phnom Penh City was the highly threatened by the flood disaster. So this is the reason the research question has been asked. The first one will be the flood magnitude be reduced if we are controlling flow from the upstream properly. And the second, how large of the flood inundation if it faced with the flood with the dam failures. In order to answer the question, therefore, our study aimed to the first one evaluate the performance of the model HEC-RAS to assess the flood inundation, and the second to assess the flood characteristic under the different upstream water release scenario. And the study applied to the lower Prek Thnot River Basin because the flood occurs mostly downstream of the basin. On the right hand side, as you can see, the map of our study area, and the left hand side is the general information of our study area. As you can see, the area around 2,500 square kilometers. It covers the southern part of the Phnom Penh and the Nandesri province. The average annual rainfall 1,002 mm, 200 mm. The maximum flood discharge over 1,300 cubic meters per second for both 1991 and 2000. In order to achieve our objective, we need to go through this flowchart. So, in order to run the model HEC-RAS, we first start by inputting data including topography and hydrological data, and then we process the HEC-RAS model by going through the HEC-RAS mapper, geometric data, and city flow data, and finally we have simulated the inundation flood. After that, we have verified the model performance both stream flow and the flood extent. After that, the first objective, we apply the scenario to obtain our second objective. And this is our first objective, which is the river discharge, calibration, and validation. The study selects for the main flood event. So based on the figure for the calibration and validation period, this model enabled to account for the peak flow and missing some low flow due to the modified river geometry with the cross-section. But overall, in this study, all the flood event passed. This model acceptable for the simulation flood inundation. So this is the result of the flood inundation from the HEC-RAS model. The study used the threshold of 0.5 meter to classify the non-flood and flood area. and the flood extent showed that over 300 square kilometers for the post 2000 and 2020, and below then 300 square kilometers in 2001, and in 2010 the flood inundation more than 100 square kilometers. So let's move to our the flood map validation. This study select global surface water to validate with the HEC-RAS model simulation. So the red spot is the flood extent from the satellite, and the blue spot is the flood extent from the model. As we can see, the flood extent from the satellite was larger than from the simulation. However, this flood extends into such some certain area as well. So the HEC-RAS model simulation flood extent with the acceptable range of 66% corresponding to the true ratio of the 0.66 in the flood event 2000, and the accuracy of the identifying the flood map is 95% in the recent year, and the highest of the model agreement of 74% for the flood map of the true ratio 0.74, and accuracy of the identifying of the flood map is about 86% in 2020. Let's take a look at our second objective result. So this is the result of our second objective by reducing flow 10% in our study. The result of the flood area was reducing around 2% compared to the baseline. However, after we are reducing flow from 20 to 50%, the flood extent decreased by more than 16%. For the increasing flow scenario, by increasing flow 10%, the resultant of the area increased by around 66% compared with the baseline. Also, after increasing flow from 20 to 50%, the flood area rise over 9%. This is the last result of our second objective. From the figure, you can see the relationship of the percentage increasing and reducing scenario have the relationship with flood inundation, with the odds were 95%. From our study, we can conclude that the model HEC-RAS is acceptable enough to determine the pattern of the inundation and magnitude of the flood in the lower Prek Thnot River Basin, and the scenario reduction and increasing flow have the linear relationship with the flood inundation area. This demonstrates that the controlling flow from the upstream will be significantly reducing flood impact in the flood-prone area. To recommend for the future study, the HEC-RAS model was recommended for the future inundation study, and the operation flow from the upstream to control the flood and at the downstream, and should be collect or measure the river cross section more. I would like to add acknowledgement to the Community Higher Education Improvement Project in Institute of Technology and the Hydrographs and Disaster Lab. And thank you all participants.